Hello, welcome to the live Q&A session with our keynote speaker, Professor Pieter Abbeel. Professor Abbeel is director of the Berkeley Robot Learning Lab and co-director of the Berkeley Artificial Intelligence Lab. Pieter's research strives to build ever more intelligent systems. His lab pushes the frontiers of deep reinforcement learning, deep imitation learning, deep unsupervised learning, transfer learning, meta learning, and learning to learn, and studies the influence of AI on society. And his lab also investigates how AI can advance other science and engineering disciplines. Pieter, welcome, and thank you so much for that very informative, engaging, and thought-provoking talk.
Well, thanks for having me, Jeff.
Really glad to have you here for this discussion. We have some questions that came in when we presented the talk earlier in the week. So let me start with some of those. And in the meantime, I want to encourage everyone in the audience to enter your questions in the chat box to the right side of the page for this session. And we'll get to as many of them as we can. So first question, Pieter, from Amit. Does reinforcement learning work even when there's a significant lag between action and response?
So I think it's a really good question because it definitely becomes harder, but it can still work. And just to dive a little deeper, when we think about response, there is two responses in reinforcement learning. Your agent, maybe a robot, is acting in the world, and it could be that the reaction to the commands you send to the robot is slow, and so there's just slow responses physically. Or it could be that what is slow is the response in terms of performance metrics. Is the robot doing well or poorly? The reward, really. And so if the dynamics react slowly, as in any control problem, high latency makes it harder to control a physical system. It's the single biggest factor that you want to reduce in your physical design and bring down to as close as possible as zero to make your problem at least a bit easier. Of course, the big thing people talk a lot about in reinforcement learning is that the reward is delayed. And especially in games, you might have to play the game for a while before the score goes up. And that response of the score going up, the more that's delayed, the harder it is for the agent to figure out how to solve the problem. And that's where some of the ideas come in that I actually referenced in the talk. Like, you can bootstrap maybe by imitating humans who have already figured out how to do it. And then the neural network has already internalized the general structure of the right behaviors. And at that point, it does become feasible again to learn relatively quickly. But yeah, learning from scratch with very delayed responses is going to be very hard. And ideally, you have a workaround that you don't need to do that.